Unicorns and rainbows. The land of make-believe, otherwise known as imaginary numbers. Those of you in Algebra 2, well, this is what the last section we're covering. We're going to graph imaginary numbers. Remember how I said you can never graph imaginary numbers? Well, today we'll learn how to graph imaginary numbers. I lie all the time in math. All right. So I'm going to give you number 1 on the assignment. Okay? Number 1. In a complex number, a plus bi, a and b are called the what and the what? The real part and the imaginary part, not the real number and the imaginary number, the real part and the imaginary part. So they're the part and the part. All right. All right. So complete the following sentence. The square root of negative b is really, if we poke out the square root of negative 1, where it's like we're poking out an eye. See, I was just faking that. I was poking out Cassidy's eye. Yeah, and I scared her really bad. So it's I square root of b. Because when you have the square root of a negative number, you have to poke out the I. There we go. Now we got some thought processes going through. All right. So 3i, how do we write that as a complex number? Well, a complex number has a real part and an imaginary part. What part do you think this is? The imaginary part. So the real part is 0. So it's 0 plus 3i. That's the written as a complex number. 0 plus 3i. Okay, the real part and the imaginary part. So the square root, write it as a complex number. Square root of 2. Is square root of 2 real or imaginary? That's real. So it's a square root of 2 plus 0i. That's how to write square root of 2 as a complex number. All right. Come on. Oh, you stupid thing.
It's because we're doing imaginary numbers.
No. Okay, so this stuff you've done in Algebra 2, adding imaginary numbers or complex numbers. So you add the real part to the real part, the imaginary part to the imaginary part. 9 plus 3 is 12. 8 minus 7i is I. So here, if we distribute our negative sign, 3 plus 3 is 6. And 3i plus I is 4i. So you can handle adding and subtracting. If we multiply, what's negative 4i times 6? Negative 24i. And what's negative 4i times negative 5i? Positive 20i squared. What is I squared equal to? Negative 1. So it's negative 20 minus 24i written as a complex number. All right. So when we do the distributive property, negative 4i times 6 is negative 24i. Easy peasy, lemon squeezy. But negative 4i times negative 5i is positive because a negative times negative is a positive 20i squared. Well, we know from Algebra 2, I squared is negative 1. So we take 20 times negative 1, which is negative 20. And since that's the real part, that goes first. So it's negative 20 minus 24i. Let's do that sort of again with a FOIL problem now. So let's FOIL this. 3 times 6 is 18. Outers plus 30i. Inners minus 30i. So nice that that did it that way. Last time's last. Minus 50i squared. All right. So these two cancel. They're gone. So it's 18 minus 50 times, what's I squared? So it's 18 plus 50, which is 68. Ta-da. Ta-da, ta-da, ta-da. I don't have to do 9, do I? Let's do 10, though, because it has radicals in it. And some of you are scared of radicals. Square root of 13 times square root of 13 is 13. Outers. I square root of 13. Inners. Negative I square root of 13. Last time's last. Negative I squared. These two cancel again. So it's 13 minus, what's I squared? 13 minus the negative 1 is 14. Let's do number 12. Okay. Square root of 11 times square root of 11 is 11. Outers. Negative 3i square root of 11. Inners. Negative 3i square root of 11. Last times last. Plus 9i squared. All right. So 11's 11. Negative 3i squared root of 11 minus 3i squared root of 11. Negative 6i square root of 11. And then 9 times I squared. I squared is negative 1. 9 times negative 1 is minus 9. So it's 2 minus 6i square root of 11. Okay. I to the 29th power. Ooh, what is I to the 29th power? Well, every 4 terms of I repeat themselves. Okay? So I to the first is I. I to the second is negative 1. I to the third is these two times each other, which is negative I. I to the fourth is negative I squared, which is a positive 1. Once you get back to I to the fifth, it's back to I again, because it's I to the fourth, which is 1 times I, and so on. So every 4 I terms repeat themselves. So I to the 29th is equal to I to the 28th times I. So you use a power of 4 to get rid of anything you need to. Because I to the 28th is 1. Just like I to the 4th is 1, I to the 8th is 1, I to the 12th is 1, I to the 16th is 1. All those are 1. So it's 1 times I, which is I. So it's 0 plus I. Because if it's in the form of A plus BI, 0 plus I. I to the 30th power is I to the 28th times I to the second. Because 28 plus 2 is 30. Okay, I to the 4th is 1, so I to the 28th is 1. Times I squared is negative 1. 1 times negative 1 is negative 1. So in complex form, it would be negative 1 plus 0i. I to the negative 12th. I haven't? Oh, I'm sorry. I to the negative 12th. Not 0. It's really, you're really close though. It's a multiple of 4, right?
It's not 1. It's I. It's I. Is it not? Also a multiple of 3. So.
Because it's a multiple of 4. Every multiple of 4 is always 1.
How did it sound a multiple of 3?
You don't worry about being a multiple of 3. You worry about being multiple of 4. So if it's I to the negative 13th, that would be I to the negative 16th times I to the 3rd. Okay? Negative numbers are a little more confusing. You have to go below it and then back up. Put your phone away. Oh, you were looking down like that at your lap, and it's like, oh, okay. So I to the negative 16th is a multiple of 4. That would be 1. And then I to the 3rd is, times. And I to the 3rd is negative I. So that would be negative I if we had I to the negative 13th. Okay? That's how that works. Nope.
How many questions are there? So what is I to the 9th then?
What? I to the 9th would be I, because it's I to the 8th times I to the 1st, which is I. How about I to the negative 9th? I just said we got to go lower than that. So it's I to the negative 12th times I to the 3rd. Negative 12 plus 3 is negative 9. So I to the negative 12th is 1. I to the 3rd is negative I. So this equals negative I.
So it's really just whatever. Okay. I need to write that down. Hold up. Where's my hands? Where's my hands? Hopefully we're not testing today. So
I to the 1st is I. I to the 2nd is negative 1. I to the 3rd is negative I. I to the 4th is 1. That's what you need to know for those problems. All right, continuing on. Find the product of the given complex number and its conjugate. What I'm thinking there, they mean by that. Yep, that's what I thought. Is you have to take 7 plus 6i times 7 minus 6i. So 7 times 7 is 49. Outers and inners in conjugates always.
cancel.
So it's minus 36i squared, which is the last part, which is 49. 36 times I squared is a negative 36. Minus a negative is plus a positive, so we get 85. The graphing part. Which one of these would be graphed as negative 2 plus 2i squared of 15? The real number is on the x-axis, the imaginary number is on the y-axis. So this is the ordered pair, negative 2, comma, 2 square root of 15. Okay? 2 square root of 15. Square root of 15 is really close to 4, right? Because square root of 16 is 4. So this is really close to 4. So this is like 2 times 4, which is 8. So it's really close to 8. So which graph has a point which is like -2, +8? B, because the point is right here. Okay? What's the absolute value of that point? The absolute value of the point is if you take the square root of this squared plus this squared. It's the distance formula, basically. You're doing the distance formula again. So it's -2 squared plus 2 square root of 15 squared. What's -2 squared?
4.
And what's 2 square root of 15 squared? So square root of 15 times square root of 15 is 15. 2 times 2 is 4. So 4 times 15 is? So this is the square root of 64, which is 8. All right, so let's graph now. Where would -7i be on this graph? Does it have a real part? No. So the real part would be 0. So it'd be like 0, -7. Because the I part is the y value. So 0, -7, it would be right there. What's its absolute value? How far is it away from 0? It's 7 away. Okay, the distance formula. Because we'd go the square root of 0 squared plus -7 squared, which is 0 plus 49, which is square root of 49, which is 7. Okay? Where's -5 going to be at? Right there. How far is it away from 0? That's the absolute value of it. Last one. Where's 5 plus 5i? What's the ordered pair is going to be at? 5, 5. It'll be right there. What's its absolute value? Ta-da! That's it. All right. So seniors, all you have to do is get these lessons done. You don't have to take the quiz. No? Yeah. So you guys just have to get the lessons done.